Solving one variable equations. So there are two main operations that we do on equations. One is we can simplify, which is to write an expression with the fewest number of terms possible. Um, Now, you can say that simplifying is getting it closer to the fewest number of terms possible, but usually we'll want to go all the way. Remember, an expression is something like x plus 2. There's going to be no equal sign if we're simplifying. Now we can simplify one side of an equal sign. We can also solve, which is to find the value that make an equation or inequality or system true. So if we see x plus 2 equals 7, we can say, okay, the value that makes that equation true is 5. It's very easy to say that 5 plus 2 equals 7, but as equations become more difficult, more complex, they become you need more challenging ways to solve them. So our goal is to get the variable by itself on one side of the equal sign with only constants on the other side. So our goal is to say, okay, x equals negative 12, or 29 equals b, or a equals 11/8. All of these are ways of saying the variable equals a number, and that says that that is the value that makes the equation true. So in this case, we had 5 plus 2 equals 7. The legal moves that you can add, subtract, multiply, divide both sides of the equation by something. So to solve is how I usually refer to that. Or to simplify one side of the equation. Pretty much every step that we do will be one of these two things. The strategy that we usually use is it's usually easy to just simplify, distribute, and combine like terms before solving. You will want all copies of the variable you're solving for on the same side of the equal sign. So when you see something like x plus 7 equals 3x minus 8, it's usually easiest to try to get that x over here. You can't just add these. We'll explain how to do that later. It is rare that dividing or multiplying by a variable will help you. Usually we will be adding or subtracting variables, and sometimes we'll be multiplying and dividing numbers, sometimes we'll be adding and subtracting numbers. And know your inverse operations. Addition and subtraction are opposites. Multiplication and division are opposites. Later, when we get to exponents, we'll say, okay, squaring and square roots are opposites. So here we have the left side is simplified, the right side is simplified. So the only thing we should do is to do something to both sides of the equation. Usually it makes sense to do the inverse operation. Here we're adding a positive 13. So I'm going to subtract positive 13 from both sides, getting x equals negative 6. And negative 6 plus 13 is 7. Now here, the left side is simplified, the right side is simplified. You could add 5 to both sides because that's the opposite of subtraction. And then we will be left with t equals 27. Here, this is 4 times z equals 17. This can't be simplified, but what we can do is the opposite operation of multiplying by 4. Dividing by 4 is the opposite of multiplying by 4, which leaves us with z equals 17 fourths. And that's a perfectly fine final answer. 17 fourths makes that equation true. Here, this is division. So division, the opposite of division is multiplication. We can multiply by 9 on both sides. And then 9 divided by 9 is 1. Please note that the reason that these were disappearing is 13 minus 13 is 0. Negative 5 plus 5 is 0. 4 divided by 4 is 1. All of those are inverse operations that then add, subtract, multiply, divide to identity elements. So 9 divided by 9 is 1. That's why this remains as y. 6 times 9 is 54. Here, we're multiplying by 3/5. So 3/5 times n equals 30. We can't simplify this side, so what we'll do is we'll do an inverse operation. You could say that we're dividing by 3/5, but also the inverse of multiplying by a fraction is to multiply by its reciprocal. By reciprocal, I mean to flip it upside down. If I do that on the left side of the equation, I must also do it on the right side of the equation. If you need to review fractions, you should know that these multiply out to be 1. These do not multiply to be 1. 30 divided by 3 is 10. 10 times 5 is 50. And lastly, we'll multiply by this reciprocal. 8 thirds times 3 eighths will be 1. 8 and 12 are both divisible by 4. And 3 times 3 is 9 over 2. If you need to review your fractions, do review your fractions. Now, here, I'm going to show you the wrong way of doing this. The tempting wrong way of doing this is to do 2x plus 6, simplify this, and get 8x equals 14. This is not allowed because this has x, this does not have x. Go back to the video on combining like terms. These are not like terms, so they can't be combined. So this is not allowed. What you can do is you can perform inverse operations. So there are 2 ways of doing this. I'll show you the standard way of doing it and another way of doing it, both of which will give us the same answer. The standard way of doing this is to say, okay, let's subtract 6 from both sides. That's an inverse operation, and that will leave us with 2x equals 14 minus 6 is 8. Then dividing by 2 on both sides, that's the inverse operation of multiplying by 2, gives us x equals 4. That's perfectly fine. 2 times 4 is 8, plus 6 is 14. That works. Now, I said there was another way of doing this. If we say 2x plus 6 equals 14, another way is to do the inverse operation of multiplying is dividing. But if we divide by 2, we need to divide by 2 everywhere. So 2 divided by 2 is 1, 1x. 6 divided by 2 is 3, and 14 divided by 2 is 7. If you will divide by something on both sides of the equation, you need to divide the entire thing by that number. Now we can do the inverse operation of addition. Subtraction is the inverse operation, and that gives us 7 minus 3 is 4. You'll notice we get the same answer both ways. This is the one that is recommended, but you are allowed to do this. What you are not allowed to do is to combine unlike terms. 2x and 6 are not like terms, should not become 8x or 8. Okay, now some more challenging examples. Here, I'm going to distribute to simplify the left side first. Now, this looks like the previous problem, where we can get rid of the 14. This is subtraction of 14, so we can do the opposite, adding 14 to both sides. 2a equals 50. Now, dividing by 2 will give us a equals 25. Here we have 2 inverse operations. If we subtracted 3, well, then this is 3/7 and k/7, so that won't help us. We'll want to get rid of this division by 7 first. Because division by 7 is the last thing that would be done to the variable, it's the first thing that we should undo. Think about it as coming into a house versus leaving a house. The door you come into first is the last one that you leave. So 7 divided by 7 is 1, leaving the numerator intact, and then we do 4 times 7 to get 28. Now, this is adding 3, adding positive 3. So we subtract 3 from both sides, getting k, positive k, equals 25. Huh, same answer. Now, 26 minus 6x cannot be simplified. Please don't try to make that 20x. This we can distribute that 2 to get 6 plus 4x. So we're allowed to simplify either side of the equation first before moving on. Now you see that there are variables on both sides. Part of our strategy, going back to strategy, you will want all copies of the variable you are solving for on the same side of the equal sign. It doesn't matter which side, but the strategy to get rid of the variable on one side is to say, okay, this is 1x. I can subtract 1x from both sides. And now there will be no x's left over, and there will be 2 x's left over on the right side. This isn't solved, but this is the next step. So what we will typically do, once both sides are simplified, we will add or subtract the variables from one side to get them all on the other side. Here I have negative 6x, so I could add 6x to both sides. Now, one of the tempting things is, where do I put the other plus 6x? You can't put it here, you can't put it here. You have to put it with the other x's. Remember, we're only combining like terms. So negative 6 plus 6 is 0. Please don't put this as 12. 6, positive 4 plus positive 6 is 10. And now this looks like this equation. So when you see things on both sides, you can add or subtract the variables, the variable expressions, in order to get them by themselves. Subtract 6 from both sides to get 20. And then divide by, well, 10 times x, so we should divide by 10. We're not always dividing by the first number. We're dividing by, when x is almost by itself, we're dividing by the coefficient of x, what x is multiplied by. If you wanted to check this, you could say 26 minus 6 times 2 is 12. 26 minus 12 is 14. And then 2 times 3 plus 2 times 2 is 4. 4 plus 3 is 7, times 2 is 14. So this number makes the equation true. Here, remember back to distributive property that when we distribute, we have to distribute that. 2p minus 1 minus 5p equals negative 4p minus 6. We have variables on both sides of the equation, so we'll be combining them somehow. But before we do that, we should combine like terms. Combining like terms is not by adding or subtracting things on both sides. It's just by combining like terms. So realize that we have positive 2, negative 5. That subtracts to negative 3. That was nothing special. This is the same. The left side has now been simplified as if there was no right side at all. Now we can add or subtract things from both sides. And remember, our goal is to get all the variables on the same side. Let me get rid of these p's. So if we add 3p here, now the p's will be gone from the left because negative 3 plus 3 is 0. Negative 4 plus 3 is negative 1. You can write this as negative p, but please know that it's the same thing as negative 1p. And the constants didn't change because we added variables to both sides. Now we can add 6. Negative 1 plus 6 is 5, equals negative p. And we don't care about what negative p is. What we care about is what positive p is. So this is negative 1, as I said before. We can divide by negative 1 on both sides to get negative 5 equals p. Last question here. This is the first thing that would happen to the variable. This is the second thing that would happen. So I'm going to undo this one first. This is a negative 1, so we're adding 1. X over 11 equals 2. And now this is division. The inverse operation of division is multiplication, so I'm multiplying by 11. So x equals 22. Thank you.